Hello, people. This is the new episode of I don't know stuff. So I already recorded this, but there were issues. So let me just close Steam before people start speaking. So what I changed since last time is change the export uh, code so that it exports every nodal data or every node, and then export the mesh divided by their name. So you have mesh 1, 2, and 3, and you can see here they have different sizes. So the first one is increases, and it's the biggest one, so it's the rock. The second one stays the same size without remeshing, so it's the file. The third one is much smaller, but it still has remeshing, so it's the putty. And so that's all there is to it. Changes from last time. So if we repeat what I already recorded, I'm just reloading the data, which I said last time, which is results and mesh. The result is pretty much the same structure as before. Then I know the velocity at which the pile displacement is displacing. I have the results dot and the time of each result extracted at. Since this is saved as a struct, if I just try to run or subdivide by my result.time, I have what I obtain is a series of scalars not connected into a vector. So what I'm doing is just place brackets around it, so it converts into one column or one row vector, and then just transpose it with the apostrophe. And so this is my well, steps. Vector. Also, something I've noticed is that if you have the ASCII data, so putty.ascii mesh and results, you can just load them back into the code, and you get, well, for example, this. You can see what you're doing, or you can see the results themselves. So first mesh, no, first mesh, the one above. Second mesh, the pile. Third mesh, the putty. So what the code I wrote previously, which I'm gonna go through again, does is goes through every mesh. You extract the results dot time step. So for each time step, you set results dot contact force, and since the contact force is a vector, you get ID of the node, component on x, y, and z, and the modulus. But so let's look at the problem. Contact force, contact force. Since we are considering just two areas, which is the pile and the or two regions, as someone would say, which is the pile and the rock around it. The putty is just a piece, considered as a piece of rock with the different properties. So the contact only happens between the putty and the pile. So, not this one, here. So I have my mesh, the given step. We know that if we want to get the contact forces, this one is not correct because it's just a mesh of the intact rock. And since we are in contact with the putty, we don't care about this one. The third one is the one with the putty, but as you can see in the results, well, toward the end of the results, the putty thins or thinnens. Let's see if I can just PT. Yeah, maybe this is more visible. The putty thins as it moves around, and so you reach a point where you have direct contact, for example here, between the pile and the intact material, or what was previously intact material. So if you want to get all the forcing acting on the pile, what I will do is just get the results on the pile itself and not on the on on either the intact rock or the putty. So in this case, we know it's the second mesh. So for each step, you have all these three nodes, and these are the nodes that we need to extract the forces from. So first, I have all the contact forces. So I just continue up to here. Selection, so I don't re-import everything. I'm just gonna comment this out so I don't have to, if I press play, I don't have to re-import everything. So I have this contact force, which is ID, X, Y, Z, total. So what I need to do is find the IDs of the nodes that belong to the pile. So I have my mesh. I don't have elements, but I have my. Oh, so I have mesh 1, which is the intact. I need mesh 2, which is the how do you call that? The pile itself. So I'm taking, continuing, I'm taking EL, which is the elements of the second mesh, which is ID and the nodes. Then I'm taking the second to fourth column, which is the three nodes. Wow, my computer was so slow. Which is ID of the first, second, and third nodes. So I'm taking all these nodes. I'm reshaping it so I don't have matrix 3 by n of nodes, but I have 3n by 1 nodes using numel, which is the product of line and number. And this gives me L, which is 1.8k nodes. And I don't know if it's visible here, but since you're sharing nodes between elements, you probably have how do you call it? Multiple entries of the same value. So I'm just doing unique, and should say to 300 nodes, which is the number of nodes belonging to. These are the nodes belonging to the how do you call it? The pile itself. What we can do is, for example, plot which is we defined earlier as all the nodes, and just the one with these values, and this should output. Let's just close this. This should just plot the nodes belonging to the pile. Let's see if this is working. I'm just gonna pause because computer's dead. Okay, and it finally plotted, and this is our nodes belonging to the pile itself. And we can do the same by plotting node x, y, and a squiggle, which is the common to plot 2D vectors, and the same with x, y, dx, and dy. Let's let it run, and well, the force is probably equal to 0 in the first step. If I just do the sum of the forces in the third row, which is the y direction, my force is equal to 0 because it's the first step. So let's just comment out all the plots since we don't care about them now. And what we can do is just for every step sum all the forces on the y direction of the elements that belong to the pile and put them in this vector, and then just plot displacement against forcing. So I'm just gonna press play and pause because completely dead. And this is what you get. The force is negative because it's just the reaction force acting on the pile. So it's correct that it's negative, and we can just plot contact force. Or it's contact force Y because it's just this one. As you can see, well, this is unreadable, but it's blue, which means it's low, which means, yeah, our contact forces acting on the pile are negative. And this is pretty much what we wanted to get. So that's one thing. And I'm gonna pause and continue next time.